Section 1.6 is about function operations and composite functions. So operations literally mean what they mean in like basic math: addition, subtraction, multiplication, division. All right. So you're adding functions, you're subtracting functions, multiplying, dividing. So, and then once you do that, you get this new function that represents the two that you added together. The addition, subtraction, multiplication, and division are really as simple as just that. All right. You are literally just adding up like terms, subtracting like terms, multiplying, which may include distribution or foiling, and then dividing, which may include factoring or, just putting them on top of each other. The only stipulation is when you divide, your denominator can't be 0, but that's always a stipulation of division. So let's look at the first example. They gave us these three functions. So they gave us the f, g, and h function. It says find each of these given operations and their domain. So the first one is they want us to add f plus g. And so we are literally going to take the f function and we are going to add it to the g function, all right, which is this guy. And so we are going to say here, x squared plus 4x plus the square root of x plus 2. Now, can I combine anything there? No, I cannot. This is my answer. Like, you're just adding. If I had like terms, like if I had an x squared in the first and an x squared in the second that wasn't under a root, I could combine like terms if I was capable of doing that algebraically. But if you can't, you're done. Like, this is it. It does want me to stipulate if there's any limitations on the domain. For this new function, would there be limitations on my domain? Is there a limitation? Is there something in this function that says, hey, you can't do something? What would be that? Right, so this piece of it right here cannot be less than 0, right? Inside my root cannot be less than 0. So you can figure out where that is. So where is x plus 2 less than 0? Well, that's when x is less than negative 2, right? And so my domain is going to be everything other than that, all right? Everything other than that. Another way to do it is to say, well, it can only be greater than or equal to 0. And so it would be greater than or equal to negative 2. Like if you're finding out where it is versus where it isn't. And so if you find out where it is, that is your domain, right? Once you have found out where it can be, that is your domain. So you've answered both pieces. You've added it up and you've let them know if there's any stipulations on the domain. Okay? Look at the minus. They want f minus h. F minus h. So we're going to go f. That's x squared plus 4x. And we are going to subtract h, which is 3x minus 5. All right? This is subtraction. The biggest deal here is worry about your negatives. All right? Worry about your negatives. So distribute that negative. We have x squared plus 4x minus 3x plus 5. You think I'm done here? No. Here I have like terms. What are my like terms? 4x and negative 3. Right. So I can say x squared plus 1x plus 5. And that is my new function. Are there any stipulations on this? Are there any stipulations? It can't be this or it can't be that. No, so this is continuous. So this is, x is just all real numbers. Or if you do, interval notation. The domain, yeah. So if it tells you to list the domain, you can list the domain. I'll take it in either one, unless I specifically tell you put it in set theory or in set notation or in interval. All right, look at the next one. They want us to multiply f and h. All right, so now they want us to multiply x squared plus 4x and 3x minus 5. How do we multiply that? What method do we use? Yeah, distribution or foiling. All right. So we're going to distribute the x squared. So that's 3x cubed minus 5x squared. Distribute the 4x. That's plus 12x squared minus 20x. Again, we can combine. Negative 5 and 12 give us 7x squared. And we are done. We can't combine anything else. And this is also continuous, right? So this is also that x is all real numbers. No stipulations on that one either. No limitations. The last one, division. They want h divided by f. H divided by f. Well, that is going to be 3x minus 5 divided by x squared plus 4x. We can factor the denominator, which I would probably recommend because then you can see if you can cancel anything to simplify it. You cannot cancel it, right? So either one of those is your answer. I'll take the one on the left or the one on the right since neither one can simplify. But I do have some stipulations on my function here. What is the stipulation on this particular function? What can it not be? 0 where? In the denominator. So something else that factoring helps me with is I want to see where this does equal 0 because it cannot equal 0. All right? And so I want to see where it does equal 0. It's going to equal 0 where this guy is 0, right? So wherever x is 0, that denominator is going to equal. And it's going to, where this guy is 0, where's that one 0? At negative 4. So it's going to look like this. Right, so that would be my domain. This would be just my division. So the only thing division does is it creates a new stipulation on the domain. The other ones really, the limitations on the domain come from your original ones, right? If there's a stipulation in one and you're adding it, it's going to be there when you add it as well. With division, the denominator, whatever that was, cannot be 0. So composition of a function is when you take one function and put it into another function. All right, when we did some evaluating on the last quiz or so, maybe the last test, there were times when there was like an x squared and you had to take the x squared and throw it into a function when you were evaluating. So you would evaluate and it would say find f of 6. And then you took 6 and you plugged it into the function. And then later on it said, well, find f of x squared. And then you took x squared and plugged it into the function, right? And so what you were actually doing there is you were actually doing a composite function when you did that. Composites, when you take one function, that means it has like a variable in it, and you put that whole thing into another function. All right, and so they've given you this. If you take the composite of f of g, and you'll notice it's this little open circle. Don't confuse it with multiplication. It means composite. What it means is you're taking the x and you're putting it into the g first, and then you're taking that and you're putting that into the f. And so it's just a composite of functions. You're working your way to the inside out, basically. Putting the x in the g and then putting that answer into the f. All right, so let's look at some of the examples they have here. They want us to do the f of g of x, the g of f of x, and the f of g of 2. All right, and they've given us these functions. So what we're going to do is we are going to take the f function. So f of x is x squared plus 1. And we're going to take the g function, which is x minus 4. If they want f of g, then we are putting g into f, okay? So we're going to take this g and we are going to plug it in for every x in our f function. So f of g is going to then x squared, but instead of x, we're writing x minus 4 squared plus 1. So we're just taking all of the g and putting it into f. So f is x squared plus 1. So for the x, we're plugging this guy in. All right, and we're going to simplify it. We can do this, right? That's just foiling. So we're going to do x minus 4, that is x minus 4 squared. And we're going to simplify that. X times x times negative 4 times x, negative 4 times negative 4. Combine your like terms. All right. And that would be my composite, taking one and putting it into the other. Now the next one they want is g of f. They want us to do g of f. So if we took those same functions, my f is x squared plus 1, my g is x minus 4. Now they want us to put f into g. So we're going to take our f and we're going to plug that into g wherever there's an x. So then f g of f then, instead of x minus 4, we're going to say x squared plus 1 minus 4. And then we're going to simplify. Obviously, the 1 and the 4 simplify here. So we have x squared minus 3. And we are done. X squared minus 3. So whatever order they tell you, you're taking the second one and you're putting it into the first one. All right. For the last one, they want f of g of 2. So now they actually want an x variable. We've actually already found f of g. That is the new function. We have found the new function, x squared minus 8x plus 17. That is f of g. So all we have to do here is plug the 2 in to every single x. So we're going to say 2 squared minus 8 times 2 plus 17. So 4 minus 16 plus 17, well, that is 5. All right? Now there's another way to do this one. I'm going to show you really quickly. If we had not already found f of g, right? Let's say we had not found f of g. You can take the 2 and plug it into the g. So we're going to say g of 2. All right? Well, g of 2 is going to be, so g, remember, is x minus 4. So we're going to say 2 minus 4. Well, that's negative 2. All right? And then we can take that answer and we can plug it into f. Negative 2, right? And remember, f was x squared plus 1. So we can say negative 2 in parentheses squared plus 1. That is 5. And so if we had not already found this new function where we could just plug it in, if we had not already found this, then we can just work our way backwards with the number itself. Take the number, plug it into the first one that's closest to the number, take that answer and plug it into the one furthest away. So you can be given ones that have restrictions. So in this case, there is an initial restriction, right? The initial restriction is that f cannot have x equals negative 1. So initially, you know from this first piece that x cannot be equal to negative 1. And so that's what you would think would be your restriction here, is that it's not going to be equal to negative 1. But what you'll find is when you do the composite, it's going to actually change your domain. And so they want us to do f of g and then include restrictions on the domain of the composite. So when they ask for it like this, you want to do the composite piece of it first and then see if there's any restrictions. So they want us to do f of g, meaning they want us to put g inside of f. So we need to plug it into here. So we're going to take f of g. By doing that, we're going to say f is 1 over, and instead of x, we're going to write x squared minus 9 plus 1. All right, and so then we're going to simplify that. That's going to be 1 over x squared minus 8. All right, So you can see that 1 is no longer a problem. I can actually plug 1 in, and I would get negative 1/7. I'd be perfectly fine. What is a problem is if that denominator equals 0. Okay? So I'm going to say, well, my domain is going to be what happens when this guy equals 0. Then we have a problem, okay? And so added over, we get x squared equals 8. Take the square root. X is going to be the positive or negative square root of 8. You can simplify that with a factor tree, right? 2 and 4, 2 and 2. I know y'all love these. That 2 comes out. So x, if x is positive or negative 2 squared root of 2, we have a problem. So x cannot equal that. So my domain is just going to be that. It cannot equal those two numbers. So I have my composite and I have my restrictions on the domain. Okay? All right, so let's look at this guy. The composite of this, they want G into F. All right, so that's what we're going to do. We're going to take my F of G, which means we're going to write x squared, but instead of x squared, we're going to say square root of x minus 3 squared minus 2. Okay? What happens when you square a square root? It just is what's inside, x minus 3 minus 2. And so this is going to just be x minus 5. So my composite here is x minus 5. That is what I want you to take the restrictions on. Are there any restrictions on x minus 5? No, it can be positive, it can be negative, it can be anything you want it to be, right? So for this one, you're just going to say that x is all real numbers. Now in the book, it went back to the restrictions. So in the book, it tells you you have to restrict it based on that square root. But it did not do that on the first one, and it is saying additional restrictions, not original. So we're going to stick with all real numbers here because there are no restrictions on that one. All right, so with this one, the first one is actually a little more simple than the second one. The first one, you can see that you have a square root and you have the function x cubed minus 4. And so what you could say is, well, I have one function that could just be a square root. And then the other piece of that could be what is in the square root. And so then I could rewrite this h of x that they originally gave us as f of g of x. Because I have one function inside another. I have one function inside another. So sometimes you can visually see, oh, this is obviously a composition of functions. Like I have this group that's inside a root. Well, the root is one function, that's one operation, and the x cubed minus 4, that's another function. So sometimes it's really easy to separate because you can see that square root and you can see there's something in the square root. And so you can rewrite it. The second one is not as obvious. So when you're given a polynomial like this, just factor it and see if you get anything that looks familiar, like looks interesting when you factor it. So if I were to factor this guy, I could take a 2 out of everything, right? 2x squared plus 10x plus 25. What are factors of 25 that add up to 10? 5 and 5. All right, there's another way to write it. When you multiply something by itself, how can you write that? Yeah, so I can do this. All right, so now all of a sudden I say, I have a group here. So one of my functions could be this guy, all right? So one of my functions could be, the inside one could be that x plus 5. If the inside is x plus 5, what are we doing to it? We're multiplying by 2, and we're doing what? Squaring it. So my other function, the one that I'm putting it into, could be 2 times something squared. Okay? So what you're trying to do is you're trying to look for a group. In both of these, we were looking for a group. So this was our inside group. So that was our second one, the inside group. And once we factored it, this was our inside group. So that was our second group. So you look for an inside group and figure out what is happening to it, all right? In the first one, what was happening to is we were taking the square root, so we did a square root. In the second one, what was happening to it is we were multiplying by 2 and squaring it. So we multiplied it by 2 and squared it, okay? And so when you're decomposing these, what you're trying to do is get it in a way where you have an inside group and something happening to it. And then you're saying, okay, the inside group, that's going to be my second function. And then what's happening to it is going to be my first function.